Hello my dear students, welcome back to NEET World. So here we will be discussing, let me check once everything is clear. Voice. Hello dear students, welcome back to Chandu Biology Classes. Here we will be discussing GATE PYQs from chemistry part. Okay, so in the last two sessions, I have covered GATE 2025 questions from chemistry subject as well as GATE 2024 chemistry subject questions I have covered right now. So those are the two sessions I have covered for upcoming GATE exam, GATE Excel. Okay, and few questions are left from GATE 2025 to be discussed. We will be discussing them, and once after completing them, then we will move forward to the one more question paper. Okay, right. So I hope you are watching all these videos and these are really helpful for your preparation. Okay, and if you have any concerns or any doubts or any difficulties, please feel free to write in the chat box. Definitely I will be looking into it and I will give you a better suggestion for that. Okay, right. So let's begin our session. So those who are in the live session, please confirm everything is clear, audio, video. Yes. So here in the last session, if you followed, I have covered this many questions. Just see this. If you are unable to answer, you can watch it. If you haven't watched or if you are unable to watch or unable to solve these questions, please go and watch the previous live sessions that I have made on these questions. Okay, so these are all questions. I hope you know that there will be 17 questions from our chemistry subject and it will be having almost like around 25 marks, right? 25 marks. Okay, so in order to get a double digit rank or a single digit rank, you should not skip chemistry part from your preparation. Okay, so you must focus on these topics to get a very good score and a good rank. Okay, please look into these questions. If you are facing difficulty to answer them, you can watch the previous live sessions that I have made on these questions. Okay, right. So these are the questions we need to discuss now. So in the last sessions I have covered up to 20 questions. The next here, so if you see, this is the question we have 22 here. The correct statement for the given reactions is R. It's an MSQ type question, multi-selective type question. So we need to answer it. Just look at this, what they have mentioned here, an aldehyde is mentioned and they are treating this with methyl magnesium bromide followed by acidic hydrolysis, right? So now what happens here? Okay, it should be very clear for us. See, I will tell you, whenever there is a carbonyl group, whether it can be an aldehyde or a ketone, what happens is there is an aldehyde or a ketone like this. Okay, it's a carbonyl group, we can say. Here we have a carbonyl group. So if you see, all these four substrates are carbonyl groups only. Okay, right. To this, we are adding methyl magnesium bromide. It means a Grignard reagent is added. So RMGX is a general formula for Grignard reagent. Okay, so now magnesium will be in +2 oxidation state because magnesium, alkaline earth metal, which is a electropositive element, right? So that's why it will be always in the positive oxidation state +2 whenever it is in the combined form. Okay, and halogen will be -1 and our halide alkyl group also -1. Since our alkyl group is having -1, so it will act as a nucleophile now. So this nucleophilic alkyl group will attack on this carbonyl group because see, between carbon and oxygen, which is more electronegative, oxygen is more electronegative now. So the bonded pi electrons will be dragging towards more electronegative oxygen atom side. So now what it will create, a positive charge, partial positive charge, that is electron deficiency created on this carbonyl group carbon. There our Grignard reagent will attacks. Okay, that gives you O- and here R group, a new R group is added here. So and here it will be forming a RMGX like this kind of salt. Okay, this upon acidic hydrolysis, what happens? Acidic hydrolysis, this O- will be taking this proton and forming a respective alcohol like this, OH, alcohol is formed. Okay, so this is how the steps should be written here, right? Now look at the thing what they have mentioned. We need to react this substrate with the methyl magnesium bromide. So whatever the steps that we have followed there, same steps you do just follow here to answer this question. See, just methyl group will attack on this carbonyl carbon side and it becomes O minus. Then next here you can write in this way, becomes O minus and a methyl group added here and hydrogen. Okay, so next what I told you, this negative charge upon hydrolysis, acidic hydrolysis becomes alcohol. So what will be the product formed? OH and hydrogen, that's it. This is our A here, okay. So this is the product here formed, okay. In the similar manner, to this aldehyde we need to add isopropyl magnesium bromide, okay. That is also a Grignard reagent only, but what happens there? Yeah, so just follow the same step that we have did. Isopropyl means you can take it like this, okay, MgBr. This is the reagent and methyl group is there on this aldehyde. So it is an ethanol, okay. So this negative charge carbon will attack here and gives you OH, EMEH. So this is our B product here. This is our B product. Okay, that's it. The next here, what they are asking for this third given compound, this ester treating with methyl magnesium bromide, but here we have taken excess. Whenever you take an excess, what happens? This ester first converts into respect to ketone, then again addition of bromide gives addition of methyl gives you an alcohol. Okay, so now what happens here is OMe is there now, methoxide. So this is an ester functional group. Whenever you are adding a methyl magnesium bromide means CH3 minus MgBr. Okay, so see this CH3 minus will attacks here and forms O minus CH3 OCH3. Okay, OMe means methoxy group. Okay, so now again this alkoxy group's elimination takes place to give you a ketone here. So this is the intermediate formed here. Again one more methyl magnesium bromide we need to add because it is taken in excess quantity, so that it will be converts into alcohol. So OH, Me and Me. So this is what the product formed. Okay, so this is our C. So C product is here. Okay, similarly we need to do it for D. What happens for D, tell me? For this fourth reaction what happens? We have isopropyl magnesium bromide with acetone. Okay, so whatever the things we have followed, just do here. Becomes OH. Yeah, so that's it. These are the products. This is our D formed in this fourth reaction. Okay, that's it. Now they are asking for these four reactions, what are the possible products from the given options? P, Q, R are given, what are the possible products? Okay, so how can we answer these? How can we answer these? See here, the first option saying the product P, the P is formed as a major product in reaction 1. Just check what is the product formed in the reaction 1. So this is a product formed in the reaction 1. Where do we have the reaction 1 product? Here we have reaction 1 product here. Is this the product formed? Methyl, no. So this is not the, yes, this is, see, methyl group is there, OH is there. So product 1 is our P. Okay, this is perfectly correct. Okay, then next, P is formed as a major product in reaction 2. So just see, this is the P they are saying, this is formed in reaction 2. This check once, are they same structures here? We are getting whatever we have got here. Yeah, are they same? Yes, CH3, yeah, methyl OH, yes. So 2 is also P. Then next, check for the C. Q is formed as a major product in reaction 4. So what is Q here? Like this. Yeah, so methyl, yes. Okay, so the D, that is Q is formed as a 4, yes, D. So I can say, so fourth reaction the major product formed is Q only, yeah, whatever they are saying it is also true. Okay, the next statement, R is formed as a major product in reaction 3. See, just say R is formed as a major product, no. See, in reaction 3 what we got, it is, since it is taken excess, we got an alcohol, but they are saying only up to here, they are saying this is a product they are represented here. No, that is incorrect, because excess of Grignard reagent taken now. So if you take excess of reaction, excess of Grignard reagent, it will be strongly attacking on this electrophilic carbonyl group, that is ketone, to give a final alcohol as a major product, but they are saying ketone as a major, so which is incorrect. Okay, so this is incorrect. So as of now, based on the options we got, so we got A, B, C are the perfect answers for the question. Okay, so like this we need to answer the each and every question. Okay, right, let's move forward. Yeah, so listen to this question once, read this question. Read the question once. Try to read this question number 23, what they are saying. See, addition of few drops of concentrated HCl to the aqueous solution of cobalt chloride forms a dark blue complex X. The correct statements for these reactions are, so there are 4 statements, again MSQ type question, we need to choose the best correct statements. Okay, right. So before going to that, see, when I have made a specific video for coordination complexes, there I have explained cobalt plus 2 color. What is the color of cobalt plus 2? Yeah, this is a question asked in previous IIT JAM BT. Okay, what is a cobalt plus 2 color? They will be giving you metal complexes and they are asking for their colors, or metal compounds and like metal ions and their colors. Okay, so if you haven't watched, you can watch coordination complexes and D block elements in these live sessions only. I mean, in this channel itself, you just go through the live section. Okay, and you can search for this coordination chemistry and D block elements, where I have discussed about the colors. Okay, it's an important topic now. Okay, now look at this, addition of few drops of HCl to the aqueous solution of cobalt chloride. Okay, so to this we are adding HCl. Okay, now what happens? It is forming a dark blue complex. So what is a dark blue complex? We have one well-known complex, that is cobalt tetrachloride with the chlorine and cobalt with charge as -2. So here charge as -2 means, what is the oxidation state of cobalt? X plus 4 minus 1 is equals to -2. So X equals to +2. So now what is the oxidation state of cobalt? See, even in the given compound, cobalt chloride also +2, in the compound also, in this complex formed also +2, and this is a dark blue color complex formed in the reaction. This is our X. Now what they are asking, see, X is a centrosymmetric complex. So the complex which we have got here, it is a centrosymmetric complex, they are saying. Is it true? No, it is false. Why it is false? Centrosymmetric means, I hope you are aware about center of symmetry, plane of symmetry, okay, all the symmetry elements. Okay, now centrosymmetric means they are saying something like center of symmetry. Okay, but in this complex there is no center of symmetry. Why? Because it is a tetrahedral complex. Why? It is a tetrahedral complex. Here cobalt is in +2 oxidation state, 3d7 4s2 electronic configuration, 4s0 electronic configuration is there in +2 oxidation state. Okay, therefore the ligand attached here are weak field ligands. Chlorides, all halides are weak field ligands. So due to that reason it will form a tetrahedral complex with sp3 hybridization. Okay, so tetrahedral means, I hope you know that tetrahedral means something like this. Okay, so this is there is no center of symmetry in this complex or in this geometry, therefore it's not a centrosymmetric complex. It is having something like this, which is a tetrahedral. Okay, so how do you understand tetrahedral? So one chloride ion towards the observer, one is away from the observer, and 2 chlorides are in within the plane. All of them are having 109.5 degrees angle. Okay, remember in this way. Okay, right. Next thing here is they are saying the oxidation state of cobalt does not change in the reaction. Yes, does this oxidation state changes or not? No, it won't change, because here in the starting material it is cobalt plus 2, and also in the product formed also cobalt plus 2. The oxidation state of the cobalt is not changed. So whatever the statement they have mentioned, it is correct. The oxidation state of cobalt does not changed. Okay, right, right. The next here, the number of unpaired electrons in the cobalt in X and in cobalt chloride are same. Yes. So just say here what is the oxidation state in the given compound. It is a plus 2. So plus 2 means it is D7 electronic configuration, D7 4s0, and in the complex also it is D7 4s0, and here it is a weak field ligand. So the electronic configuration, whenever there is a weak field ligand, the electronic configuration of central metal will not be altered. It will be same as like a free metal. Okay. Therefore, electronic configuration in this cobalt chloride normal case and after product formation, both of them are having same. So it is also here same. So the number of unpaired electrons on cobalt in X and cobalt chloride aqueous medium are same. Okay. This is perfectly correct. Okay. Now they are saying co-solution. Okay. Okay. So the next one here, the spin only magnetic moment value of X is 3.87 they are saying. Yes. So let us see whether the statement is correct or not. Cobalt plus 2 is there. Cobalt plus 2 means how do you write? This as, okay, this has 3d7 4s0. So 3d7 means you can represent in the orbitals 1, 2, 3, 4, 5, 6, 7. Okay. So these are the 7 electrons we have. Since the ligand used here is weak field ligand, so there is no alteration in the electrons of this d orbital. So that will be remains as such, because only this vacant orbitals like s and p orbitals only utilized. So these are the only 3 unpaired electrons. So the number of unpaired electrons are 2. Therefore, magnetic moment mu is equals to root over n into n plus 2 Bohr magnetons. So how many unpaired electrons we got here? 3 now. So mu value will be root over 3 into 3 plus 2, that is a 5. Root 15 we got. Root 15 is nothing but root 16 means 4, but it is 15 means, yeah, we will be getting around 3.87 only. So whatever the value they have mentioned, it is perfectly correct. So B, C, D is your perfect answer for the question. Okay. Yeah guys, if you see this, it's a MSQ and 2 marks questions, okay, which are very easy. So I suggest you one thing, just watch the coordination complexes video that I have made, only 2 sessions I think so on this D block elements and coordination complexes in this channel itself. Just go and watch it, and definitely those are helpful for your exam. Okay, right. The next here, 24th question. Question says the correct statements regarding the biomolecules is are. Again MSQ type question. So tell me. So you should be aware of this biomolecules topic. See what they are saying, the N-terminal amino acids of a polypeptide can be identified by Edmonds reagent. Yes, Edmonds reagent, that is nothing but phenyl isothiocyanate is called Edmonds reagent. So this phenyl isothiocyanate will selectively reacts with the N-terminal amino acids. Okay, yeah. So this is perfectly correct. Okay, and what about this? L309 has only 1 chiral centers. And one more thing guys, you should be aware of all 20 amino acid structures. Okay, yeah. In the last paper also, in 2023 paper, in the previous discussion, 2024 paper, in the previous discussion I told you, I mean there is a question I have shown you, like indole ring containing amino acid, like histidine, like indole ring, imidazole ring, or pyrrolidine ring. Okay, which is most basic amino acid. These are some questions we can make by looking at the structures, okay, without having any chemical properties. Just by looking at the structures we can construct those questions, right? Okay, and only the secondary amino group present in which of the following amino acids they may ask. Okay, So if you see, for all 20 amino acids, the nitrogen atom will be primary, but in the proline, okay, so in the proline if you see, the nitrogen atom is secondary nitrogen, right. So that is a exceptional, I mean that is a thing, that is a specified thing we need to be remembered, okay. Yeah, we need to look at the each and every difference of the all the amino acids, what makes it to be special, okay. Here if you observe L309, see all amino acids, naturally occurring amino acids have like L configuration, we know, okay. Now they are saying it has only one chiral center. Will you accept this? No, it has two chiral centers, na. So what are the two chiral centers? So one is the one which is having both carboxylic and amino group, and the other one, the adjacent one here, contains OH group, okay, and CH3. If you observe this, there is one methyl group, one hydrogen, one hydroxy group, and this alpha chain this side. So it means this having 4 different groups now, so it is a chiral carbon. Here also we have this as a chiral carbon. So how many chiral centers are there? 2 chiral centers are there. So now I will make one more question here. So in the given organic compounds, if there is n number of chiral centers, number of possible stereoisomers they may ask. So the number of possible stereoisomers are 2 power n. So if there is n number of chiral center, so 2 power 2, those are 4 stereoisomers are possible for that compound. See, for this particular question there are 2 chiral centers, so you can say this as an incorrect statement. This is done. Now I am adding an extra point here. What is that? In the given organic compound, there are n number of chiral centers, let us say. Therefore, number of stereoisomers possible for that molecule, if they ask, you should take it as 2 power n. So where n indicates number of asymmetric centers or chiral centers in this case. So 2 power 2, because 2 chiral center, so 4 stereoisomers are there. So what is this stereoisomers are? Yeah, so in the last class I told you, whenever we say a compound is optically active, okay, it should contain either chiral center or it should not have any planar center of symmetry, right. So now with one chiral center there are 2 optical isomers, okay. One is called as R isomer, another called as S isomer. Since I am saying there are 2 chiral centers in this complex, in this compound, it can be RR compound, or it can be RS compound, or it can be SR compound, or it can be SS compound. So how many possibilities we got? 1, 2, 3, 4 now. So it can be SS. 1, 2, 3, 4 now. Yeah, these are the 4 stereoisomers possible for a compound if it contains n number of chiral centers like this, okay. So I hope this extra point is also clear, right. Let me explain you one more question. Cytosine is present in DNA and RNA. Will you accept this? Yeah, we have ATGC and AUGC, right. So we have here in both case cytosine is present. So this is perfectly correct, okay. It's very easy. Next, a mixture of 2 different amino acids can be separated by ion exchange chromatography. Yes, this is also correct. Why it is correct? See, ion exchange chromatography, when we are doing amino acids, we know that it has polar groups, right. Now the carboxylic acid and amino group is there. Now they can exist in the zwitterion form also. By changing the pH, one amino acid may be in the normal state, another might be in the zwitterion state. So now what happens, one is having more polarity, other having less polarity. So one which is having less polar will travel longer distance and will comes out faster than the other polar one, right now. Because whenever there is ions, that will be strongly held to the stationary phase, right now, in this ion exchange chromatographic techniques, okay. So based on that, we can ion exchange chromatography based on the polarities, yes, we can separate them. So a mixture of 2 different amino acids can be separated by ion exchange chromatography. So I can go with A, C, D as my answers for the question, okay, right. Let's move forward. So look at this, what they are saying, energy of the transition from NH, that is 4 to NL, that is 2, for hydrogen atom is 3 into 10 power 3 centimeter inverse. See, energy mentioned in centimeter inverse, okay. So here you can say wave number, okay. So given Rydberg constant for hydrogen is this much, okay. We need to calculate the value of E, that is energy we need to calculate. It's very simple. See, we have an equation, that is 1 by lambda, that is a wave number, that is nu bar is equals to, here they mentioned it as energy in this case, no worries. You just take energy will be directly proportional to nu bar here, because energy inverse is proportional to wave length. Okay. So here RH, what is the formula you can use here? RH z square 1 by n1 square minus 1 by n2 square. Okay. So now here n1 n2 is there, now always n2 should be greater than n1. Okay. Then this formula works well. Okay. So here, yeah, so here E is equals to, if I wanted to write RH, what is the RH? Rydberg's constant they have mentioned now. So how much it is? 1.097 into 10 power 7 meter inverse into Z square, atomic number for hydrogen atom. You can take it 1. So for they mentioned helium, so atomic number is 2 now. So Z square means 2 square you should take for helium ion. Okay, but hydrogen atom mentioned, so it is 1 only. 1 square means 1 here. Okay, and 1 by n1, so which is lower number here, so n1 here 2 is less now, so 1 by n1 square, that is 2 square, 4 I can write, and 1 by n2 square, bigger number here is 4. Okay, so 4 square here, that is 16 I can write. Okay, smaller number first, n1 should be lesser than n2, like that you need to take here. So this becomes E is equals to, see I can write wherever I have meter, there I can write 10 to the power 2 centimeter, 100 centimeters. Since here it is meter inverse, can write 10 power minus 2 centimeter inverse. So I can write 1.097 into 10 power 7 in the place of these, can write 10 power minus 2 centimeter inverse, and upon simplifying this you will get denominator 16, 4 minus 1 is 3, that's it. You can write it like this. Okay, so this becomes 10 power 5. So E can be 1.097 into 10 power 5, okay, 10 power 5 centimeter inverse into 3 by 16 we can write. What is the E value they have mentioned there? E into 10 power 3 centimeter inverse we should write. So centimeter inverse, okay, 10 power 3, 10 power 2 means I can write it like this. So E can be now 109.7 into 3 by 16. Okay, so just to simplify this you will get the answer. Okay, yeah, so try to round it up to the 2 decimals based on the calculation. Just use the calculator to get exact answer. Do not make a rough calculation, make exact calculation, because we know there will be boundaries for the answer, right? 25, upon simplifying you will get 20.56, okay, by simplifying this. Okay, right. Then next here we have next one more question. I hope you got what to use whenever they are giving electronic transition. So from which chapter it is? It is from structure of atom, right? So if you haven't watched this session on structure of atom, please you can watch. It is available in our channel itself. Okay, just go through the live section, everything is mentioned. Okay, the next question is 26th one. Yeah, so this question is also important model. See what they are saying, a non-volatile solute is added to a solute has a molecular weight of this much, okay, 180. Assume that the solution does not undergo dissociation or association, okay, in water, and the boiling point constant, that is ebullioscopic constant of water, is 0.51, okay. Then the amount of solute to be added to the 500 grams of water to elevate its boiling point by 0.5153 Kelvin. It's very simple, man. Just listen to me. See, I have a container. In this container we have only solvent, that is water is my solvent. What we have? Only water we have. Okay. So to this water, how many grams they have mentioned? The amount of solute to add it to 500 grams. So water, how much quantity I have taken? 500 grams of water I have taken. So this is weight of solvent I can say. Okay. So we know this water boils at 100 degrees Celsius, that is they boils at boiling point of solvent, that is T naught B. Okay. So how much it is? It is 100 degrees, I can write 373 Kelvin, right. Now what I wanted to do, I want to elevate the boiling point of water from 100 degrees to somewhat bigger. How much bigger, how much extra more? So this much amount extra I need to increase the boiling point. It means instead of boiling at 100 degrees, water should now boil at somewhat like 101, 102. That is what elevation means right now. So we need to add something to elevate the boiling point. So what we can add? Yes, we can add some electrolytes. Now what happens? For example, if we add NaCl, what happens? It will elevate the boiling point of water because NaCl is a non-volatile component. When we add it to the water, what happens? It will decreases the vapor pressure of water. Since vapor pressure is decreasing means boiling point increases. Okay, so vapor pressure decreases, boiling point increases, right? So now we have a formula to calculate this. The elevation in boiling point of a solution is equals to kbm, okay, or I can simply say IKBM, where I indicates Van Hoff factor. See, if it's an here they are saying it's a non-electrolyte, it will not undergo association dissociation. If it is not undergoing any association dissociation, you should take it as 1. And what is the abelioscopic Kb value they have mentioned? It is 0.51. It is 0.51. Okay, and with what temperature they need to increase it? The boiling point elevation should be this much. How much? 0.153. Okay, right. The next what we need to do? M, molality. What is this? M means small m here indicates molality. So molality you can write it as weight of solute by molar mass of solute into 1000 by weight of solvent. Weight of solvent. So you can write here M means weight of solute. This is the amount of solute we need to add to elevate the 500 grams of water to this much temperature. Boiling like molar mass of solute is 180 grams. Yes, you can take here 180 and here it is 1000 by weight of solvent is 500 grams. That's it. So this will be 2 times. Okay, this will be 90 times. Weight of solute to be added can be taken as 0.153 into 90 by 0.51. Okay, so you can simply write it as 51 and this is 15. Okay, you can make it as 2 zeros. Yeah, 15. Yeah, so you can write 153 into 9 by 51. Okay, so how much it is? See, 51 is a 51 3s are 153. So 3 9s are 27. So you can get 27 grams. So how many grams of solute we need to add? 27 grams of solute to be added into the 500 grams of water to elevate the temperature by this much degrees. Okay, I hope you got the concept. Okay, so in the same way they may ask us for depression and freezing point. When they are asking for depression and freezing point, you just need to use this formula. Delta TF is equals to I KFM. Okay, so here cryoscopic constant, here it is ebullioscopic constant. Here also small m means molality, same as above, and I means Van Hoff factor. Sir, we are not having idea on Van Hoff factor. No worries, I will tell you. KCl is there, so it's a strong electrolyte now. So whenever I place this KCl electrolyte in water, what happens? It will dissociate like K plus and Cl minus. Now how many ions we got? Initially before dissociation we have 1 particle, right? But after dissociation how many particles it is releasing? 2 particles now. So it means I value should be taken as 2 here. Okay, so I value is how much? 2, because number of ions formed after dissociation, association we need to take here. Okay, because it's delta TF, osmotic pressure that we are studying in osmosis or osmotic pressure, elevation, boiling point, depression and freezing point, these are colligative properties. It means what? They depends on number of solute particles. See, KCl is a solute from which we are getting K plus Cl minus. These are solute particles only now. Yeah, our colligative properties depends on this number of solute particles. Okay, so that's why we should not ignore the number of particles formed by dissociation or association, because previously at the initial case we have only KCl, but once after placing in the water it will automatically dissociate to give you 1 K plus 1 Cl minus. So we got 2 solute particles now. So if 2 solute particles are there, our colligative property value will also be changed. Okay. So that's why it is mandatory to introduce this number of particles into the equation. That is what the importance of I here. Okay. If you are not introducing I, you are going to get a wrong answer. Okay. I hope the concept is clear. Along with the question, I have explained the extra things that to be required here. Okay, right. So now what you need to do is take any of these PYQ book, or if you are not having them, so just go through the Google and download these sheets, I mean these GATE PYQs, question papers you download, and if there is a question, this is a question from solutions chapter. Okay, if you are not having any books, my best suggestion to you is just go through any NEET or JEE books. Okay, it can be NCERT books or it can be any materials. Okay, just look at these model questions. Okay, because they will be repeatedly asking the same models, not exactly the question but similar model or similar concepts. Okay, now what you need to do, you just practice 2-3 questions from depression in freezing point, 2-3 questions from elevation in boiling point, and 3-4 questions from osmotic pressure, like this. So this is how you can make your confidence boosted. Okay, right. Right. Let us move forward. Yeah. One last question from this 2025 paper. Jyoti Rani A and C. Okay, see, whenever you are answering in the comment box or in the chat box, please mention question number also, so that I can fix the exactly what you are exactly giving me. Okay, otherwise it is difficult to identify for which question you are answering. Okay, right. Let's move forward. One last question we have from this paper, and you know there will be one electrochemistry question. See, what is the trend we have observed in the papers is definitely one question from electrochemistry and one question from coordination complexes, okay, and one question from chemical kinetics. Okay, like this, you just go through the paper and analyze the papers and mention me what are the chapters and what are the topics they are focusing. Okay, because we can also focus more on those topics itself from each and every chapter and the question papers or some model questions at least. Okay, so look at this, the standard potential E naught for the Fe plus 3 to Fe conversion, and for these conversions are given in this way. Okay, then next they are asking what is the value of Fe plus 2 to Fe conversion in moles. Okay, they are asking potential value. Okay, so it's very easy, standard potential value, finding standard potential value. See, if you observe what are the ions they have mentioned, Fe plus 3 mentioned, and Fe plus 2 also mentioned, and Fe mentioned. These are the three things they have given. Okay, so if you observe, the first reduction potential is from here to here. Okay, that's it. Okay, and second reduction potential is from here to here, right? And the third reduction potential, that is what they are asking us, is from here to here. Okay, so let us number this as 1, 2, 3. So in this way let us number it. Okay, now what I can make, 3 is equals to 1 plus 2. Can I write like this? Yes. So 1 plus 2 gives you 3, right? This is how you can make. Okay, and they are asking us standard electrode potential for this reduction. Okay, it's very easy. What to do is, for every change there is something called Gibbs free energy, standard Gibbs free energy. Okay, so this is delta G01, this is delta G02, this is delta G03. Please listen to me, because we can expect a question again from this. Okay, these are the things they will be giving you. Okay, so what I can write, delta G03 is equals to delta G01 plus delta G02. Okay, like this you can write. Okay, so now what do we mean by Gibbs free energy change, standard Gibbs free energy change? This is nothing but maximum work done, that is minus like charge into potential here I can say. So here minus NF, so N indicates number of electrons, F indicates Faradays. So NF charge into potential, that is E naught of that cell, NF E naught cell. Okay, right. So here delta G3, so from plus 3 to 0. So how many electrons are involving? 3 electrons now. So you can write this as minus, let me write this, minus NF E naught 3 is equals to minus NF E naught 1 plus minus NF E naught 2, like this you can write. So we have negative signs here, so remove them. Right. The next number of electrons in third process is how many? 3 electrons. So 3F E naught 3 is equals to, and in first process how many? Only plus 3 is converting to plus 2 means 1 electron. So 1F E naught 1 plus second process how many? Plus 2 is converting into 0. So 2 electrons, 2F E naught 2, like this you can write. And if you see F is called Faraday here, so it's a constant, Faraday constant, that is 96500. So F I am removing, that's it. Okay, now finally what is the relation we have here? So 2 E naught 3 is equals to 1 E naught 1 plus 2 E naught 2. This is what they have mentioned, that's it. Now if you observe, they have mentioned this Fe plus 3 to 0, that is E naught 3 is mentioned as this much. Okay, reduction only, yes, reduction potential only mentioned. So that is 2 into minus 0.04 is given. Okay, and Fe plus 3 conversion to plus 2, that is first value is mentioned as plus 0.76. So 1 into plus 0.76, and they are asking this E naught 2 value. So 2 into E naught 2 you can write. Okay, yeah. So now try to simplify this. So this will be minus 0.08, and if you send this side, it also becomes minus 0.76. Okay, is equals to 2 E naught 2. Okay, like this we can write. So minus minus you can add them place, it becomes so 8 plus 6 14 now. So 4 1, that is 8.0. Okay, like this we will get. Okay, that much. Okay, that's it. So 2 E naught 2. Okay, so you can remove 2 times, this will be 0.42. So what is the value of E naught 2? E naught 2 equals to minus 0.42. I hope you got this, how we are solving. Okay, so 6 plus 8 14, so 4 1, so it becomes 8, 0.84 we got, minus 0.84. Here we have 2 times, so 2 means 0.42 minus 0.42. So this will be your numerical answer to be mentioned in this bracket, because they are asking us to round off to 2 decimals. Okay, 2 decimals, that's it. Okay, right now, do you got the concept, everyone who are watching this? Or any confusions are there? Please mention if there is any confusion. Right. So yeah, we have till now we have finished 2025 complete questions. Whatever the questions we have in GATE Excel 2025, we have finished them. Now let me show you some questions from GATE 2020 paper. GATE 2020 paper, for practice purpose it will be useful. Yeah. So from here we have some questions. Okay. So yeah, let me change the questions once. Yeah. So there are some questions. You can watch it from here. Yeah, this is a better 1, 2, C. I think it's clear, it's clearly visible. Yeah, so just read the question. The correct order of first ionization energies for helium, boron, nitrogen and oxygen in their corresponding ground state is. So they are asking what is the ionization order they are asking. What do we mean by ionization energy? See, if there is an element E, the energy required to remove an electron from this neutral gaseous isolated atom of this element is called its ionization energy. So this E should become now E plus and one electron should come out. See, to removing out one electron we require some energy now, so that energy is called ionization energy. You can understand in this way. So now if it have a stable electronic configuration, removal of electron is difficult. So removal of electron is difficult now, so it requires higher energy. So now just look at the elements that we have here. Helium we have, okay, and nitrogen, oxygen, boron, like this we have. See, helium is a noble gas, it has 1s2 electronic configuration, so it is very difficult to remove the electron from helium. So always noble gases will be having highest ionization energies in their respective periods, okay, remember. And down the group if we go, so the one which is at the top will be having highest ionization energy, because down the group size increases, easy to remove the valency electron because it is away from the nucleus, okay, right. So helium is the highest one in the given options, okay. After this, if you write their electronic configuration like oxygen and nitrogen, you can see for nitrogen we have 2s2, 2p3 electronic configuration, for oxygen 2s2, 2p4 electronic configuration is there. See, here it is having a stable half filled configuration in case of nitrogen. So the removal of electron from this stable electronic configuration is difficult. That's why nitrogen is greater than oxygen, okay. After that, boron least. So where do we have this kind of option? Yeah, helium, nitrogen, oxygen, boron. Yeah, this is option A, okay, right. Guys, if you haven't watched this classification of elements and periodic table from our Chandu Biology classes, just go to live sessions and check. There is a specially dedicated session for these topics, okay, like ionization energy, electron gain enthalpy, all these things are discussed. You please go and watch if you are not aware of this. And you know, I told you previously, I told you few compulsory chapters like chemical kinetics, electrochemistry, coordination compounds, and you can add one more chapter, that is molecular orbital theory, that is chemical bonding. From chemical bonding we can expect 2 questions, not even one, we can expect 2 questions, okay. One is 1 mark, other one is 2 marks, okay. Yeah, so in the NEET in the 2025 paper also I have shown you 2 questions, okay, right. So here, and particularly they may ask it from valence shell electron pair repulsion theory, okay, that is by giving you a compounds like this ICl2 minus and NH3, and let me add few more questions here, few more options, and here I am writing SF4, like this they will give you 4 options and they mention their structures this side. They will mention the structures or their hybridizations and they will ask. So how can you calculate for this kind of compound? See, what is the central atom here? Iodine, right now. So iodine means its group number, like what is the group number? Halogen from the group 17 now. So take valency electrons, 17 means 7 valency electrons are there. So 7 plus chlorine atoms, it's a monovalent, chlorine atom is a monovalent, halide ions are chloride, like monovalent. So how many are there? 2 are there, add 2. So if there is a negative charge, add the electrons. How many negative charges? 1 negative charge, so add plus 1, divided by 2. So how much you are going to get? 10 by 2. So 5 now. So 5 means hybridization will be sp3d. So this is the hybridization. With this hybridization, there is 2 surrounding atoms, means out of 5 only surrounding atoms are 2, remaining 3 are lone pairs. So sp3d means trigonal bipyramidal it should be, but only surrounding atoms 2 are there, then you are going to get a linear shape. What you are going to get? A linear structure, okay, like a line, okay. It means I in the middle, so this side one chlorine, this side another chlorine, so lone pairs around the iodine, like that, okay. Hope the discussion is clear. Now what is the angle they may ask? It is just 180 degrees between 2 chlorides, Okay, so for ammonia how can you do? So just now I told you what is the group number of nitrogen, it is 17th group. Now you put 7 electrons, 15th group. Now you put 5 electrons, 5 valence electrons are there in nitrogen, okay, like this. So how many hydrogens are there? 3, like this. So 3 bonds over and 1 is lone pair. So 3 sigma bonds, 1 lone pair. So total is 4. 4 means sp3 hybridization. sp3 means here 4 should be there, but 3 surrounding atoms are there, 1 lone pair is there. So in that case what happens, ideally sp3 means it should be tetrahedral, but in tetrahedral 1 position is occupied by lone pairs, remaining 3 positions are occupied by bond pairs. So due to that lone pairs it will be getting a pyramidal geometry. What we are going to get a pyramidal geometry here. So can you tell me what will be the answer for SF4 from our discussion? Can you tell me what will be the answer for this SF4? And if you are not knowing about this concept, I have clearly with very tricky ways, in the simplest manner possible, I have explained complete chemical bonding, I mean important topics of chemical bonding. Just watch it, it will be available in our Chandu Biology Classes live sessions itself. No, so someone are asking, can we skip organic chemistry? No, dear, please do not skip organic chemistry. See, because we can expect 3 questions to 4 questions again. Easy questions I am saying, 3 to 4 easy questions from organic, which everyone can able to answer if you know little basics. Okay, so yeah, so what I suggest you is, instead of skipping them, try to focus on the questions, I mean the concept that I have asked in the previous model papers. I mean if you take any PYQs from last 5 years, you just take 5 to 6 year papers, you just take and analyze what type of organic questions they are asking. Okay, are they belongs to same model? Yeah, mostly they will ask you about substitution reactions like SN1, SN2 and the next elimination reactions, and after this stereochemistry part they will ask you. Okay, right. So stereochemistry sessions, see guys, once again I am saying you, if you are not aware of this stereochemistry part, please go and watch my session. See, I have made complete sessions by looking at the IIT JAM BT questions, but those are equally important for your BT JAM, I mean this one, GATE Excel and GATE B also. Okay, so just watch, utilize those live sessions that I have made here. Right. The next, yeah, the next here, what they are asking. Second question here, this is from molecular orbital theory. What they are asking, based on molecular orbital theory, which of the following statement is correct? Okay, see, they have given N2 molecule. I will see in the last sessions, whenever I discuss a question related to MOT, I will try to insert maximum tricks possible in the discussion. See, N2 is there. So how many electrons we have here? N2. Nitrogen atomic number is 7. So N2 means 14 electrons should be there. It's a molecule. So 14 you write. Okay, and after that N2 plus, it means 1 electron is removed from N2, it becomes N2 plus. So here we have a 13 electron system. Next, O2 is there and O2 plus is there. So O2 plus means it has oxygen atomic number is how much? 8. So O2 means it should be 16 electrons molecule. O2 plus means remove 1 electron becomes 15 electron. Like this you can write. Okay, so I will tell you one tricky way to solve this. Whenever we have 14 electrons, the bond order to be 3. What's the bond order? We'll get 3. Okay, if you increase 1 electron or if you decrease 1 electron, bond order decreases by 0.5. So here 14 becoming 13 means what is the bond order? It becomes 2.5. Okay, and here 14 becoming 15 means what I told you, again decrease by 0.5, like this 2.5. Again decrease the 16th electron, again decrease by 0.5, it becomes 2.0. Okay, these are the bond orders we got. See, the bond orders of N2, O2, N2 and O2 are higher than the respective cations. See what they are saying, bond order of N2 is greater than its N2 plus. Yes, this is correct. And bond order of O2 plus O2 is greater than its cation. Is this correct? See, O2 bond order is less compared to O2 cation. So it means O2 is, see what they are saying, bond order of N2 and O2 are higher than respective cations. No, I will not accept this, because in case of nitrogen it is valid, but in case of oxygen it is not getting correct. See, O2 having 2.0, but O2 plus bond order is 2.5. See, O2 plus is greater now, so it means option A is incorrect. Okay. The next statement, the bond energy of N2 plus is higher than N2. Yeah. So just check bond energy. See, more is a bond order, greater is a bond strength. Okay. Greater is a bond energy. Okay. And lower is a bond length. Okay. This relation you can remember. So where do we have this one? Bond energy of N2 plus is higher than N2. Okay. See, bond energy, greater the bond order, greater is the bond energy. So greater bond order for N2, not N2 plus. So bond energy should be greater for N2. See, nitrogen is having more bond energy, that's why it is used in car or vehicle tires. Okay. The wheels, like bus wheels, if you observe, the tires or tubes are filled with the N2 gas. Okay. You might be aware. Okay. Due to its high bond energy. So bond energy of N2 is higher than, no, this is incorrect. Okay. Next, here the unpaired electrons in N2 plus and O2 plus represents are present in sigma and pi star orbitals respectively. How do you know this sigma and pi star orbitals? You need to write the molecular energy diagram here. Okay, it's easy. Whenever there is 14 electrons here, you can follow this. Sigma 1 is, sigma star 1 is, sigma 2 is, sigma star 2 is. Okay, so pi 2p x equals to pi 2p y. And next, sigma 2p z okay, so sigma 2p z. Next, pi star 2p x, pi star 2p y, and least is sigma star 2p z. Like this you need to write the orbital energy diagram whenever electrons are 14 or less than 14. So now it will be valid for nitrogen because it has 14 electrons. See, 14 means 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. Okay, up to here we have filled the 14 electrons. Now read the statement they have mentioned. The unpaired electron present in the N2 plus is which orbital? Whether it is sigma or pi star they are asking. Okay, so which orbital it is? Yes, so it is present in sigma right now. So for N2 plus it is sigma only, because for 14 this many. So 14 means if I make N2 plus, I am removing one electron, it becomes 13. That last electron is present here only now, right? So statement up to for nitrogen it is clear. For O2 plus we need to verify. How can you verify? See guys, just I am explaining, that's why I am taking this much time. But once after getting clarity on this topic, you can do within seconds. Okay, no need of wasting this much time also. But if I do that much fast, most of students are unable to understand. That's why making it as slow as possible. See, when it is having electrons greater than 14, electrons greater than 14, more than 14 electrons, then follow this. Sigma 1 is, sigma star 1 is, sigma 2 is, sigma star 2 is. Okay, here we got pi now, so do not write pi now, you just write it sigma. Sigma 2p z, next pi 2p x, pi 2p y, then write these things. Pi star 2p x, pi star 2p y, last as sigma star 2p z. Okay, now fill those 16 electrons. See, more than 14 means here oxygen plus 2, it means oxygen molecule is 16, but oxygen cation 15. So 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, and 15th electron is in this pi star orbital. So they are saying yes, the cation, the odd electron, the unpaired electron present in the pi star orbital right, this is perfectly correct now. Yes, it is present in pi star orbital. So option C is perfectly correct. Okay, now one more last statement they have mentioned, the bond order in N2 plus is shorter than N2. Yeah, tell me. So the bond in N2 plus is shorter than N2. So N2 plus bond is shorter than N2. It means bond length they are asking. What I told you, bond order and bond length, how do they relate it? Inversely. More the bond order, lower is the bond length. Okay, more bond order is for En2. So it should have a lower bond length. So bond length should be greater for N2 plus. The bond length in N2 is shorter than no. So this is also incorrect. So option C is your perfect answer for the question. Okay, right. So now the next question is about diboron molecule. So you just try to get me the answer, like diboron means B2H6. How do you write the structure? So boron, boron, hydrogen, hydrogen, H, okay, H, like this. Okay, so this is the structure you can draw, and based on this you just justify the 4 options and give me the perfect answer. Okay, and tell me what is the hybridization of each boron in the diboron. It's a very important molecule to be understood. Okay, and give me your answer for this question. Okay, and the remaining things will be discussed in the upcoming session. So just stay tuned with this our Chandu Biology classes for more updates. Okay, so thank you for watching. Stay connected. Thank you.